Welcome back, students, to the chapter Haloalkanes and Haloarenes of class 12. In this part, we are going to see about nomenclature of polyhaloalkanes. So in the last part, we saw nomenclature of monohaloalkanes. In this part, we are going to see polyhaloalkanes, how to name them. So first we will see the nomenclature of dihaloalkanes with the same halogen atom. So first we will see with a alkane with two halo groups, and that too the same atoms, same halogen atom. So dihaloalkanes with the same halogen can either be named as alkylidene halide or alkaline dihalides. Alkylidene halides or alkaline dihalides. So when will we name the compound alkylidene and when will we name the compound alkaline? This we will see in the later part of this slide. Okay. So the point is we have to name in trivial naming there are special names for such compounds. These dihaloalkanes with the same halogen. So that special name is given here, alkylidene halide and alkaline dihalides. So let us consider an example. In this case, we have one carbon atom, so it is a methyl group, and we have two chlorine. So if you're looking into IUPAC naming, you can call it as dichloromethane. So it is like this, dichloromethane. Whereas as I said, in common naming, it is called having one carbon atom, so methylene dichloride. Methylene dichloride. So if there is more than one carbon atom, for example, for instance, if you have two carbon atoms, you can classify them as geminal or vicinal. So if dihaloalkanes, if it has more than one carbon atom, it can be classified as geminal or vicinal. How? So in this case, you can see this is the parent hydrocarbon is ethane, and onto the ethane two chlorine atoms are attached. These two chlorine atoms is on the same carbon, isn't it? So if you are looking to the IUPAC name, you can say that 1,1 dichloroethane. 1,1 dichloroethane, or you can call it by the name ethylidene chloride. So among these two names here, ethylidene is suggested because it's a special case where we have both chlorine on the same carbon atom. So they have this special name ethylidene chloride. Clear? And since it is on the same carbon, they are classified as geminal or gem dihalide. So this is a group where we can call them as geminal. And what is the peculiarity of this one? So in this case, we have both the chlorine atoms on the same carbon. So both X on the same C atom. On the other hand, if we have an ethane where chlorine is on the two neighboring atoms, then we call it as vicinal. So this is vicinal, vis dihalide. What is its name? IUPAC is 1,2 dichloroethane. On the other hand, we have the other name for the compound, that is ethylene dichloride. So ethylene dichloride. So this ethylene, the name comes from normally CH2 double bond CH2 ethene is called ethylene. So since these two chlorine atoms comes by breaking the double bond, it is called ethylene. Its trivial name is from that, ethylene dichloride. On the other hand, this is slightly modified. If chlorine comes here, it is called ethylidene. So this di from here is taken. So you can see di is not here, is taken and is added in between in between L and E, in between ethyl. So it is like this, ID. So this di is taken from here. It's put here in the reverse order. That is a ethylidene chloride. So when is this added? It is added when two chlorine is attached to the same carbon atom. So again, while in the nomenclature of polyhaloalkanes, first we are seeing dihaloalkanes. In dihaloalkanes we have two types of namings, that is, it can be either alkylidene if both are on the same carbon, and it is called dihalides, alkaline dihalides, if it is on the two carbon atoms. If there is only one carbon, then we have the general name, that is methylene dichloride. If it is more than two carbon, then you can name either as alkylidene if we have chlorine on the if we have both halogen atoms on the same carbon, or you can simply call as alkaline dihalides if it is on the two carbon. If it is on the same, we call it as geminal, and if it is on the neighboring carbon, we can call it as vicinal. Clear? So X is on the adjacent carbon atoms. So this is in general, though the name is ethylene dichloride, in general we can say it is alkylidene halide, and in the second case it is alkaline dihalide, alkylidene halide and alkaline dihalide. So in this slide we are going to see some of the general polyhaloalkanes, their nomenclature. So the first one is CHCl3. So this name we have mentioned in the previous part, CHCl3. So its common name is chloroform, a very known compound, chloroform CHCl3. So what will be its IUPAC naming? IUPAC naming it has only one carbon, so its parent is methane, and I have 3 chlorine. Since I have only one carbon, you don't have to number it, so it is trichloromethane. Chloroform is the common name and IUPAC name is trichloromethane. So in this case, this compound chloroform, the name chloroform is quite famous, and sometimes normally we don't use this name. Often we use this name, but still for the board exams they might ask this name or this name, so you should know it. So chloroform CHCl3 has IUPAC name trichloromethane. So we are looking to the next, CHBr3. So here it is chloroform. So if instead of chlorine, if it is bromine, then it is bromoform. Clear? Again, tribromomethane. And if it is iodine, then we call it as iodoform. Clear? Iodoform, and triiodomethane is its IUPAC. So next, CCl4. So as the name suggests, it is again another important compound, that is carbon tetrachloride. Its common name, whereas its IUPAC name is tetrachloromethane. So carbon tetrachloride is its common name and tetrachloromethane is its IUPAC naming. So among all these compounds, chloroform and iodoform are two important compounds which we will see again. Chloroform is already a known compound for you, I guess, whereas iodoform is an important compound which we will see later. There is a test called iodoform test. And this one CCl4 serves as a very good solvent for many organic compounds. Also chloroform. These two serves as very good solvents for many non-polar compounds. Clear? So this is about the nomenclature of polyhaloalkanes, some of the important ones. Now, again we have this compound polyhaloalkanes, which is dichloro. So as you can see, 1, 2, 3, 4. So the parent is butane, and we have 2 chlorine attached to the first carbon. So what will be its name? Its name is 1, comma. So if you are numbering it, this carbon will be getting the first number. So 1, 1 dichlorobutane. 1, 2, 3, 4. The butane is the parent hydrocarbon, and both chlorine is attached to this one. So we can call it as 1, 1 dichlorobutane. Next one, here again we have 1, 2, 3, 4 carbon atoms. Again it is butane, parent is butane. So I will number it. So we have 1, 2, 3, 4 carbon atoms, and if I am numbering from this direction, then also it will have the same carbon atoms where chlorine is attached, 1 and 4. So it is 1, 4 dichlorobutane. 1, 4 is the same numbering. Clear? Now next compound. Here I have chlorine. Here I have two methyl groups here. I have again chlorine and methyl group here. Then I have chlorine here. So what will be the name of the compound then? Name of the compound will be, if I'm numbering it, how can I number the compound? I have to find out the longest chain, isn't it? So the methane is arranging, one is here and the other one is here. Methane, one is here, one chlorine is here, which means that I have 1, 2, 3, 4, 5 and 6 branches. So I will draw it. So I have one methane here, one methane here. So I have one CH3, one methane here and one chlorine here. I have one chlorine here and here. So in order to get the preference for numbering, I can clearly see that branches are concentrated more on this side rather than, okay, now I think that the branches are equal, isn't it? So I can number from both the sides. Either of the sides I can prefer 1, 2, 3, 4. So it's like that. And you know that chlorine is concentrated on this side and C comes first in the alphabet. So I will prefer this side for naming. Clear? Numbering can be done from any side, but here we have two methyl groups as branch. Here I have one methyl and one chlorine. So if you are counting the branches, taking the sum of the branches, both are same. But if you are counting from this side, one of the branch has the alphabet C, which is much earlier than methyl group. So I will give that preference to C, since the C will get lower number if I am counting from this side. Okay, so I am counting from this side then. So it will be like 1, 2, 3, 4. So the parent is butane, and we have on the first carbon, on the second carbon, and on the fourth carbon we have 3 chlorides. So 1, 2, 4 trichloro, and I have on second carbon and we have one methane, and on the third carbon I have 2 methane. So 3 or 2, 3, 3 trimethyl butane. So let us see the writings. 1, so I have 1 comma, then I have on the second one 2, I have a chlorine, then 4 I have another chlorine. Clear? So it is 1, 2, 4 trichloro, and I have then 2, 3, 4, 2, 3, 3 trimethyl butane. So next, here there is a difference. They have given the name and I have to draw the structure. So this is for the first time we are seeing a type of this. So write the structure from the following name of the compounds. Okay, so let us see how to do it. So first we have, first compound is 2-chloro-3-methylpentane. 2-chloro-3-methylpentane. So first what we have to look is what is the parent here. It is pentane. So first step is to draw the skeleton of pentane, of the parent. Okay, so we have C, just leave some space between first carbon and the next dash, always like that. So we have 4 carbon now, and I have the fifth one. So it is 5 pentane. Then on the second carbon I have chloro. So start from any end. So if you are marking this carbon as 1, should always keep that order. So on the second carbon atom we have chlorine, and on the third carbon atom I have methyl group. One methyl group. Clear? Now what I have to do is I have to complete or fill the balance of carbon. So I have already one bond here, which means that I have to fill 3 more hydrogen atoms. To complete it, I have already 3 bonds here, so I have to fill 1 hydrogen to the second carbon atom. For the third, the same. In the fourth case, I have to fill 2 hydrogen atoms, and in the last one I have CH3. So this is how to draw the structure. Clear? So you first write the skeleton, then try to fill in the branches, then remaining valence must be filled with hydrogen atoms. Okay, so molecule, that is, as I said, I have 2 chloro, 3 methyl pentane. Now second one, 1 chloro, 4 ethyl cyclohexane. Here I am having a compound that is hexane, but it is a closed chain compound. Cyclohexane. It's an alkane. It does not have any double bond. So people often used to make mistakes, may confuse it with benzene, but you should not confuse it. It is cyclohexane. So cyclohexane means it's a 6-membered ring. So I will draw it, that one first. So I have a cyclohexane. If you count 1, 2, 3, 4, 5, 6 carbons. Clear? So I have 1, 2, 3, 4, 5, 6 carbons. Now what are the branches? It has 1 chloro, 4 ethyl. So if I am considering this as first carbon atom, here I have 1 chlorine, and here I have 1 ethyl group. So let us write it. So I have chlorine here on the first carbon atom. So this is 1, 2, 3, and this is fourth carbon atom. Here I have ethyl group, that is CH2, CH3, ethyl group. So the branches are completed. Either I can leave it like this, or you can, if you are interested, you can simply fill the number of hydrogen atom. On the first one I have 3 bonds, so 1 hydrogen. On the second one I can fill, I have 2 bonds, one is this one is this one, so 2 hydrogen to be filled. Again here on the third carbon atom, again 2 hydrogen, here 1 hydrogen. So like that you can completely fill the valence of each carbon, or you can, if it is a ring, you can leave the skeleton like that. Clear? If it is a ring, you can leave this. So in the second one you can first draw the skeleton. Then if you are drawing C inside the skeleton, you are supposed to write H. If C is not there, then you don't have to write H. If C is there, so let us see. H, CH2, CH2, everything is filled, and we have one more here, that is C2H5. So this common, or you can write it like this, simply like this. If you are writing just the skeleton, you don't have to write H, or if you are writing C, then you have to write the H here. Clear? Now the third one, 4 tert-butyl. So they have given the trivial name of the special branch, IUPAC accepted branch, that is tert-butyl. 3 iodoheptane. So let us see. Heptane means it has 7 carbon atoms. So if I am drawing it, so I have 7 carbon atoms. 1, 2, now 3, 4, 5, 6, 7 carbon atoms. And on the third carbon atom I have iodo group, which means that if I am taking this as number 1 carbon, if this I am taking this number 1 carbon, it has third carbon has an iodo group, and a fourth carbon, that is this one, fourth carbon has tert-butyl. So what is tert-butyl? Which means that the branch is butyl and the main branch is attached to the tertiary carbon. So let us see how it will work. So it is like this. I have attached to a tertiary carbon of butyl group, and I have 3 more carbons. So C, C, C. Clear. Now I am filling CH3, CH2, CH, CH, CH2, CH2, CH3. So this is H, CH2, CH3. Now if I am filling this side, this is already complete, and this is CH3, this is CH3, and this is also CH3. Okay, so this is how to write this compound, tert-butyl. Let us see that compound. So it will be like this. On third carbon atom, I have this iodine, and on the fourth carbon atom, I will have this tert-butyl, which I can make short like this. Clear? So whenever you are seeing naming in my classes, try to draw it in a piece of paper so you will be familiar. Once you are doing this repeatedly, then the naming will be quite easy for you. Now fourth one, 1,4 dibromo-butene. Butene means it's a butane that contains double bond in the second carbon atom. So it's 4 carbon atom that has a double bond in its second carbon. Also it has 2 bromine attached to one first and the last carbon atom. So we will try to draw it. I have a skeleton of 4 carbon atom. Clear? And in the second carbon, that means here I have a double bond. On the first and third I have bromine. Of first and fourth I have bromine. Bromine. So if I fill remaining, I have CH2 here. So this is CH, CH, and again I have CH2 here. So CH2, CH, double bond CH, CH2. On both CH2 at the ends I have Br attached. And the last one, 1 bromo, 4 secondary butyl, 2 methyl benzene. So benzene is having a very similar structure to cyclohexane, but with a alternative double bond inside. So we will try to draw that too. So I have benzene, with the alternate single and double bond, or instead of that you can put a circle inside it to show the resonating structure. Now if I am choosing this as the first carbon atom, on the first carbon atom I have bromine. Then on second carbon atom I have a methyl group. And on fourth means this is 1, this is 2, this is third one, this is fourth one. So on the fourth one I have secondary butyl. So butyl means it has 4 carbon atoms, and secondary carbon, this is the secondary carbon. Clear? So it is attached to the secondary carbon. So what will be the name then? Will be CH3, CH, CH2, CH3. So this is the compound. So it is the compound where we have bromine on the first carbon atom, methyl on the second, and fourth have a secondary butyl branch. So that's all about the naming in this part. We will continue with the naming in the next part.